Good morning, and welcome to our final presentation for the Collaborative Workflow Seminar. We're group number 5, that consists of Marisa, Hesham, and myself, Herman. Today we're going to talk about the digital workflow we have created for a studio project called Luna One Residence, that is a residential community in the moon. For this project, we embrace 4 major pillars: the concept of modularity, adaptability, self-assembly, and individuality. So the idea is that we create a series of modular components that can adapt to the different circumstances on the moon. They can also be self-assembled using digital fabrication and robotics, and it can also embrace the concept of mass production and mass customization. In this way, we can celebrate the individuality of each one of the members of the community. For this reason, we design a series of parts that makes the whole system, and we define 3 different levels: micro, meso, and macro. Micro level, where we design the parts; meso level, when we define how the parts relate to each other; and the macro level, that is when we create the total aggregation. For this, we create a rule-based aggregation system that is a stochastic aggregation using WASP, the grasshopper component. And as you can see here, this is a quick diagram that shows how the community grows and evolves based on the needs across the different phases. This is now a project workflow that we started as a single Grasshopper script that takes care of the project, the entire process, and then through the introduction of the speckle system, we managed to break this script into 4 different personas and to be able to keep a live connection of each one of the stages of the process. Due to the complexity of a process and the high level of automation we want to keep, we then design an own app. And for this reason, we use human UI. We call this app the Luna Configurator. This configurator takes care of the entire process. When you start with the client, when you define the site location and position and defines the brief, then you pass it into the designer that design the parts and the components and then define the rules of aggregation using WASP. Then pass it into the engineer that it runs 3 different analyses: radiation analysis, structural stability, and also distance and walkability analysis. And then as a final process, once the client approves and reviews, then it goes into the digital fabricator that makes use of Rhino Insight to then create different documentation process and the quantity takeoffs. This is now the screenshot of the Luna configurator. And as you can see, we have 5 major tabs, and each one of them is related to one of the personas of the project. Each one of the tabs takes care of one part of the process, computes the information, and then pass it using speckle to the next different persona. Here are the different project roles. As we said before, we have 4 different personas that start with the client that defines the brief, the location, the aggregation, then into the designer that defines the part, the small attributes and the connections, then the engineer that runs the multiple analysis, and then we have the digital fabricator. Now I'm going to pass it into my colleague Marisa, she's going to explain more in detail the project workflow. Thank you.
So here is a diagram of the workflow and the roles in our speckle stream. We have the client, the designer, the engineer, and the digital fabricator. So the client here would give us site information and aggregation numbers of different units that they would require in the initial volume and the constraints, which then goes on to the architect to aggregate these in terms of design and in terms of the aesthetic and the looks. And then it goes on to the engineer who will then analyze the radiation and analyze the structural to get an optimized selection of seed. And then when it gets passed on to the client, whether they approve it or yes or no, and if it's a yes, they will then pass it to BIM, which will push it to Rhino, and it will be it will go to the fabricator for fabrication. So here are the total streams that we have in this project using Speckle. 5 total streams, and within the streams, the way we have structured it is that we've passed it through branches depending on the data that is within the stream. This is because we want to have easier work, easier sending off the data. If it's a big data, we have some big aggregations. We need to divide it into these branches to be able to push it through to the next person taking on the data. Here, we have the client data stream, and as I mentioned before, they give us a starting point and the parts quantity so that the architects can then aggregate them. Here is the view, the Rhino view from the client of the points and the volume streams. And then the architect will then push through BREFs, points, and curves for the analysis for structural and radiation. And here we see the client review, what is being pushed to the client so that they can make a decision. The architect stream would have all these different data of the aggregation, planes, BREFs for each units. And in the engineer, they will be receiving performance report in terms of number value and the visuals of the performance analysis. This is from the architect aggregation. And here is a view of the analysis. So then this is the loop that is able to, we are able to do this loop however many times we want, depending on the client. If there are changes and comments, it will go back to the engineers and the architects in terms of maybe new parts or new location. So this will allow them to just go on to the configurator and make some changes and then pass it back on to the second loop, back to the client for their review again. And if that is approved, it will go on to BIM. So here we can see that in the case of it's approved, it gets sent on to Rhino Speckle via, it gets sent on to Rhino Insight via Speckle and through to Revit to produce the drawings. Go next. These are the outputs that we are able to achieve from to be able to push through to the fabricators, the number of parts and the details of these things. And the structural quantities, the envelope quantities, and these are the drawings. And Hisham?
So now we can see like a video for the whole process. So the first part is like the client is defining the starting point, the volume, and the initial locations for the aggregation. And then the architect is start to identifying like different parts quantity and the seed values to get the desired solution for the design. And then he's sending all of these data so the structure engineer and like other engineers can have it. And in that, like engineers are receiving all of these parts and all of these elements through Speckle. With receiving these elements, then they can preview like the model, and then they can run different simulations, structural workability simulations and solar radiation simulation. And then going back to the architect to inform the design, and then the architect can again change the seed and the quantities, and then again send all of these data. And again, the engineers can receive the updated data and update them using Speckle, and then again run different simulations to achieve the better solution using values coming out from these analysis data. And then from that, data are sent to the BIM team, so he can again receive all of these elements, and using Rhino inside, they can push all of these elements into Revit, and then automated levels and drawings are exported from Revit. And again, another cycle, so like client at the end can receive all of these data using a stream to preview the model on his PC. Thank you.
Thanks.